Hello, I'm Jim Salisbury with Mitsutsuya America Corporation, and welcome to the Metrology Training Lab. In this episode, we're going to discuss calibration, which is critical to maintaining the quality and accuracy of your measuring equipment. Unfortunately, there is a lot of confusion in practice associated with what is calibration. It's been our experience here at the Metrology Training Lab that this confusion in calibration is very costly to organizations, sometimes directly in poor use of your calibration dollars, but more importantly, by increasing quality risks that could explode into costly problems with your products. Let's start with an example. Say you have hired somebody to calibrate this Mitsutsuya linear height gauge. What do you expect they will do? And are you sure they know your expectations? Is it enough for them to, say, take a few readings on some gauge blocks, put a new calibration label on the unit, and give you a calibration certificate with those readings? Did you expect them to compare their readings to a tolerance? And to what tolerance? Did you expect them to make adjustments to the accuracy if the unit is out of tolerance? And are length measurements alone enough, or are there other important items to check on this linear height gauge? There really is no single or correct answer to these questions. It depends on what you need. Now, in our experience, there are 5 distinctly different activities that are often called calibration. So let's start with a review of the basic concept of calibration. In its simplest sense, calibration is about transferring some measurement unit, like length in inches or millimeters, from some traceable measurement standard to another piece of a measuring equipment. For example, this Mitsutsuya Checkmaster here, I could calibrate this using a comparison technique, for example with these gauge blocks, and transfer the traceable length from the gauge blocks to the Checkmaster. Now let's get a little more official, as there are national and international standards that define the term calibration. Let me get my glasses and I'll read you the most widely accepted definition of calibration. This is from a document called ISO IEC Guide 99. Otherwise known as the VIM, or the International Vocabulary of Metrology. So, according to this definition, and by the way, you can download a free copy of this document, the VIM, from our on-demand educational resources at mitsutsuya.com. All right, so here we go. Here's the definition of calibration according to the top experts. It's an operation that, under specified conditions, in a first step, establishes a relation between the quantity values with measurement uncertainties provided by measurement standards and corresponding indications with associated measurement uncertainties, and in a second step, uses this information to establish a relation for obtaining a measurement result from an indication. So did you get all that? So I'm sorry, I have to apologize. I had to be complete and give you this official definition, but it's quite a mouthful. So much for the theory. Let's get more practical. What the second part of that definition is saying is that calibration really begins with an understanding of how you are using the measuring equipment. What that means is, as the owner of the measuring equipment, you need to realize that how you are using that equipment impacts how it needs to be calibrated. And since not everyone uses measuring equipment in the same way, that leads to different organizations having different understandings of calibration practices. All right, as I said earlier, what we've learned over the years here in the Metrology Training Lab is that there are 5 very different activities in practice that are commonly called calibration. So let's use this linear height to discuss these various types of calibrations. One of the most common goals of calibration is to see if the accuracy of the measuring equipment is within some specified tolerance limits. This type of calibration is often called a test, or a conformity acceptance test, or a verification. For this linear height gauge, this type of test is often done using a length gauge like this Checkmaster that you see here. It would involve taking a series of linear height points at various locations. I can zero on the surface plate and then move over and measure on the Checkmaster. And I would compare that measured value with the calibrated value of the Checkmaster. The resulting error is then compared to a tolerance. So this conformity acceptance type of calibration does not apply to all measuring equipment. For example, for this Checkmaster, the purpose of calibration, or what I need as the owner of the gauge in order to use it the way I want, are the calibrated values, or the reference values for each point on the checkmaster. In the calibration of the checkmaster, there are no tolerances to be checked in the calibration. So we see with these two pieces of equipment, the calibration of the checkmaster and the calibration of linear height, we need something different from calibration. The checkmaster needs the reference values, and the linear height needs to be tested to see if it conforms to tolerance. These are the first two types of calibration. Now, but before we discuss the third type of calibration, what we need to talk about is what needs to get calibrated on your measuring equipment. For this linear height, if you're only measuring heights, then this test with the checkmaster for height measuring accuracy is the only thing that you need calibrated. However, this linear height has additional functions. It can measure things like straightness and perpendicularity. And if you're using these additional functions, then you need additional stuff to be calibrated. For example, we have a ceramic square over here. And if I'm not using the straightness and perpendicularity functions, then I don't want to waste my money getting that calibrated. So as the manufacturer of the height gauge, we can give you some advice on the calibration. But the ownership of what needs to be calibrated belongs to you, the user of the measuring equipment. And with today's sophisticated measuring equipment, this is a real problem. Organizations are often not getting the right things calibrated, which can waste money, or even worse, expose your organizations to risks associated with quality. All right, now let's move on and discuss the most controversial use of the term calibration. There are times when measuring equipment needs to be adjusted, or corrected, or tweaked, or compensated to make it more accurate, possibly to bring it back to within the specified tolerances. These adjustments, as important as they are, do not meet the official definition of calibration. Now please don't get mad at me for this or post nasty comments. I'm just the messenger on this one. Honestly, in our experience here in the Metrology Training Lab, a majority of organizations that we work with will claim that in their opinion, calibration includes proper adjustments and that measuring equipment isn't calibrated unless it has been demonstrated to be working within tolerance. So this is a big problem in the calibration business. You could hire somebody to calibrate this linear height, they could do some tests, find the height to be significantly out of tolerance, and they could still issue you an accredited calibration certificate with those results. And they could still stick a new calibration label on the instrument, hand you an invoice and say, all done, possibly without ever discussing the out of tolerance condition with you. So this bothers me, and I hope it bothers you as well. This is a problem born from the different historical usages of the term calibration and also price pressure. If you are hiring somebody to do a calibration, protect yourself by being clear in your purchase orders. Don't just say, calibrate this gauge. As we often see in this business, instead, be more specific. Say something like, calibrate Mitutoyo linear height. Check against the accuracy tolerance for height and straightness and perpendicularity if you need that. Perform manufacturer recommended preventive maintenance. Make necessary adjustments to be within original manufacturer specified tolerance limits. Report the as found readings prior to any service and adjustment, and then report the as left readings after all the final adjustments. And finally, issue an ISO IEC 17025 accredited calibration certificate. Okay, we've discussed three different activities often called calibration. The determination of reference values, as we would want for this checkmaster, a conformity test against tolerance, as we would want for this linear height, and the question of adjustments. There are two other calibration activities that we need to discuss that are a little less formal and usually done by the user in the routine daily use of the measuring equipment. On this linear height, for example, there are interchangeable probes. When each of the different probes is used, at some point, the diameter of the tip of the probe needs to be calibrated. On this linear height, this is usually done with this probe diameter calibration block. These type of user calibrations are quite common, from tip sizes on things like coordinate measuring machines, the magnification for optical systems, the detector gain adjustment, even the zero setting on large outside micrometers. So these calibrations need to be done correctly, as they are often tweaking some temporary adjustment to the measuring equipment. If I'm off 5 microns when calibrating the probe diameter, all my measurements will be off 5 microns. It's also important to recognize that doing this probe calibration is not calibrating the entire instrument. Measuring equipment that has these user calibrations still need to be calibrated, as in the first 3 types of calibrations we discussed earlier. Okay, the 5th and final type of calibration we want to discuss in this episode is sometimes called verification of calibration, or interim test, or check standard. So to reduce risk between full calibrations, which may be a year or longer, many organizations like to implement some type of quick interim test to monitor the status of the measuring equipment. These are usually shortened versions of a full calibration. For example, in this linear height, the user may have, say, 1 single gauge block that's measured every month or every week or possibly every day, depending on the acceptable level of risk and the use of the linear height. So there you have it, 5 very different activities that are sometimes called calibration. We'll post a summary of those at the end of this episode. I hope you've learned a few things that will help you reduce risks in your organization, and the next time that somebody asks you to calibrate something like this linear height, you should ask, do you need this calibrated, or probably just calibrated? And I assume you want it calibrated if needed. And don't forget to check the calibration and always do a calibration before use with this calibration gauge, which, by the way, also needs to be calibrated. Thank you. I'm Jim Salisbury, and we'll see you next time from the Metrology Training Lab.